Today we're going to be talking about how to solve exponential growth and decay problems. They're all word problems, and here is your general formula where n sub 0 is your initial amount, how much we start with, I-N-I-T-I-A-L, your initial amount of anything. It could be dollars, it could be grams of substance, it could be organisms or whatever. E is of course the number. K is your rate, your growth rate or your decay rate. If it's decay, then the rate is negative. If it's growth, then the rate is positive. Okay, if we're talking about money, this is always as a decimal. So they might give you a rate as a percentage. You always want to change it into a decimal. And usually, if you can, have 4 decimal points. Okay, 4 decimal point accuracy. And T is the time in years or days or whatever the units happen to be. N is some future amount. How much are we going to have after 10 days or 6 hours or 18 years? Okay, so future amount, this is your initial amount, n sub 0, n the number at time 0, k is your rate, t is your time. That's exactly what this says. K is positive for growth and negative for decay. Future amount, initial amount, time, and rate. So let's do some problems. 40 bacteria in a petri dish increase at a rate of 14% each hour. How many bacteria will there be in 6 hours? So 40, this is your n sub 0, your initial amount. 14 is your rate. As a decimal, that's 0.14. And 6 hours is your time. So the amount equals 40 e to the 0.14 times 6. So let's bring up our calculator. Sorry, it's a large screen calculator right now. Let me move it over a little bit so you can see. We have, I guess it won't let me see. I'll move it over here. So 40, E is the second natural log button, and that's raised to the 0.14 times 6. So e to the 0.14 times 6, press enter. It turns out that there will be, in 6 hours, 92.65. In other words, 92 bacteria. Because we can't have half of a bacteria. Anything that is living, you can only have whole numbers of. So our 92.65, we can't have 0.65 of something, so we just take it down to 92. Always round down with live things. Okay, next question. $10,000 is invested in an account with an interest rate of 4.25%. So again, this is your initial amount, your initial investment. This is your rate, 0.0425. How much money will be in the account after 8 years? That is T. So these are just straight plugging in. We want to know the future amount. How much will be in the account? 10,000 e to the 0.0425 times 8. Okay, these are all numbers, so we put this all into our calculator. 10,000 e, second natural log, to the 0.0425 times 8. Because this is money, we're going to round to 2 decimal places, so dollars and cents. So $14,049.47. I don't know if the bank will give you that half percent and round up or not. Let's assume that the bank will not. So $14,049.47. Let's assume the bank is stingy and will not round that 47.5 to 48 cents. So that's how much money will be in the bank after 8 years. Okay? Which means we have earned, if this is the question, you have earned $4,049.47 in interest. Just as a side note. That's how you make your money work for you. You put it in an account and let it sit there and grow exponentially. The longer you leave it in, the more money you earn. How long will it take that $10,000 to double? Okay, so here we have a doubling problem. Double 10,000 is, so this is our future amount. In the future, we want to have $20,000. So now we have $20,000 equals our original $10,000 e to the rate 0.0425. In this case, we're trying to figure out t. How long is it going to take? Time. So we have 3 steps to solve any one of these whenever you have something in the exponent. Your first step is to divide. We divide both sides by 10,000. We're trying to solve our variables here, so we're trying to get everything away from our variable. So 20,000 divided by 10,000, well, that's 2, hence the doubling factor. E to the 0.0425 times t. So here we have an exponential, and from our previous things we solve exponentials by taking the natural log of both sides. So now we're going to natural log both sides. Natural log, natural log. Okay, this is very good because the natural log of e is the number 1. And we can bring this to the front, this times 1, this in essence cancels itself out, no smiley face there. So we're left with the natural log of 2 equals 0.0425 times t. So our last step to solve for t after we natural log both sides, and that cancels out the e, is to divide once again by our coefficient 0.0425, and let's bring up our calculator. The natural log of 2, make sure you close your parentheses, divided by the rate 0.0425, enter. So after 16.3 years, that $10,000 will double. 16.3 years. So in general, there's actually a doubling formula, if you'd like to know this one. The doubling formula says, when we divide here, we get the natural log of 2. And if we divide that by the rate, that will give us how long it takes to double. So this is a nice formula. Notice what we get at the end. Natural log of 2 divided by the rate gives you the doubling time. So if you can remember this, then you don't have to worry about going through all these calculations anymore as far as figuring out the doubling time goes. So here we have Sam. Sam's initial investment of $3,500 doubled in 9 years. At what interest rate did he invest? So from our previous problem, we figured out that the natural log of 2 divided by k would give you the time that it took to double. So if we want to solve this for k, we can have a nice equation for the rate. So we times both sides by k. We get the natural log of 2 equals t times k. So if we divide both sides by t, you find that we have a very similar equation for the rates. So if time is the natural log of 2 divided by the rate, that means the rate is the natural log of 2 divided by the time. So our rate was the natural log of 2 divided by 9. Notice the amount that you start with doesn't ever matter, because what matters is that when you divide this, you're going to get a factor of 2. So it will take $3,500 the same amount of time as it takes $10,000 to double, as long as it's doubling at the same rate. So figuring out the rate, natural log of 2 divided by 9, the amount of years, and you get 0.077. So k is equal to 0.077. So if we times that by 100, we can change this to 7.7% was the rate at which Sam invested. Even if he would have invested $20,000, it would have still taken 9 years to double if he got an interest rate of 7.7%. So the amount of money initially invested doesn't matter. It is the rate that makes your doubling speed up. Here's a neat, nice problem. At the dentist, Joe was given 2 milliliters of Novocaine to numb his mouth. After 4 hours, only 0.8 milliliters of Novocaine was left. At what rate of decay, what was the rate of decay for Novocaine? So here we have an initial amount. 2 is your n sub 0. We were initially given 2 milliliters. This is our time, t, and then here is our future amount. This is a, or n sub, or just n. This is n sub 0, some future amount. So we plug these into our equations. We have 0.8 equals 2e to the 4 times k. In this case, we want to figure out what k is, the rate of decay. So our 3 steps for solving any exponential. First step is to divide. So we'll divide both sides by 2. Get rid of that there. 0.8 divided by 2, I believe is 1.6. It's like we're multiplying it by 2 rather than dividing by. That is not true. This is 0.4. We just divided it by 2. We did not divide by 1/2. So 0.4. Our next step is to natural log. So it's natural log both sides. Natural log of 0.4, natural log of e, and of course this cancels out. So we're left with a natural log of 0.4 equals 4k, and our last step is to divide. Divide both sides by 4. Oops, I meant to change the color. Divide by 4. And what we'll figure out is that this value, the natural log of this decimal, this is going to give you the negative. Because the natural log of decimals is always going to be negative. They are below the y-axis, so they're negative values. So let's see, the natural log of 0.4, close parentheses, divided by 4, negative 0.22907. So because this is not money, I'm not worried about it, so I have negative point, what was that, 22907. So we'll round up to 2291. So basically 23% is gone after 4 hours. So there's your rate. Negative 0.2291, what we should expect because it's decay. Okay, let's see what else we have here. A certain strain of bacteria can grow from 40 organisms to 75 organisms in 6 hours. So here is your n sub 0, this is your n, and this is your t. So find the growth constant, k. Alright, so 75 equals 40e to the 6k. Well, in this case, a's, a sub t. This is a here, and this is your amount. So just a little bit different version of the same equation. This is your initial amount always, and that's your future amount. So let's do our steps. Our first step is to divide. Okay, we'll bring that up and decimalize it real quick. 75 divided by 40. 1.875 equals e to the 6k. Next step, natural log. Okay, over here it cancels out. Over here this gives you some nice decimal, so natural log of 1.875. We'll calculate that in a second when I actually divide it one more time. The last step is to divide, so we divide both sides by 6. So going to our calculator, natural log of 1.875, close parenthesis, divided by 6. Okay, we have a rate of 1.048. We'll round up here to 4 decimals, 1.1048. 0.1048. So that's your K value, which is good because we're going to use it down here. Use the K found above to find how long it would take that bacteria to grow to 900. So here, this is our future amount. So we want 900 equals our original 40 organisms. Remember, this is still the amount we started with. Still 40. E to the 0.1048 times T. How long will it take before we get to 900? Okay, so once again, divide both sides by 40. Oh, there's the bell. I'm going to pause and, well, no, it's finished. Take the natural log of this and then divide all that by 0.1048. So let's see if I can do this all at one time. Natural log 900 divided by 40. That gives you this amount right here, divided by 0.1048. That gives us a 29.7 years. Or in this case, let's see, what was our hours? So our time is equal to 29.7 hours. Okay, because our original amount was in hours, so this amount is also going to be in hours. Okay, good to go.